Okay, number 5 here says, what's the difference between isotopes of the same element and what subatomic particle is always the same in all isotopes of the same element? Now, first of all, you need to know what isotopes are. Isotopes are identical, same element. So, for instance, lithium, lithium, lithium. They're all the same element, but they have different number of neutrons. So neutrons are the big key here. Neutrons change, and therefore they change the mass of the atom. Protons are always the same in all isotopes of the same element. So lithium, in this case, always has 3 protons. So if you look at the picture, the blues are the protons. 1, 2, 3, 1, 2, 3, 1, 2, 3. What does change are the number of neutrons. This one's got 3 neutrons. 3 protons plus 3 neutrons for the first one. 3 protons and 3 neutrons equals 6 total. So that's going to be your mass number for that particular element. And we see the mass number written right there. Protons, mass number. This one, we've got 3 protons, atomic number 3, but then we've got 4 neutrons. So we've got a grand total of 7. So that's going to be 3 protons, 4 neutrons equals 7 for a mass. And this one's going to have 3 and 5 and 8 for a mass. So what's changing here are the number of neutrons and the mass number changes. But what never changes are the number of protons. That's locked in stone. If you change the number of protons, then you have a different element. Number 6, how can you mathematically determine the number of neutrons in an atom if you're given its atomic number? Well, if you're given the atomic number, then that means you know the number of protons. And if you're given the mass number, you can subtract. You know the grand total, and you know the number of protons. This is like saying if you know how many kids are in the classroom and you know how many girls there are, you can subtract and figure out the boys. So you subtract protons from the total, and you can get the neutrons. Subtract the girls from the total, and you can find out the boys. All right, let's complete this table. I think we're going to be able to see everything that we need to see. Okay, this is kind of like a puzzle. You have to know what things are equal to each other, and that'll help you solve this. So let's start off with the first one here. We know we have 8 electrons and 9 neutrons. Now, if you have 8 electrons, we're going to assume that these are all dealing with unhappy atoms, unless you're in the noble gas range. But these are 8 electrons and 8 protons, so those two things are equal. If you have 8 protons, then we can go up to the periodic table and figure out what element it is. And if you look up here, because we do have to shift down a little bit, if you look up here, element number 8 is oxygen. That's got 8 protons. So let's take a look back at our table, knowing that we have oxygen. So we can fill in oxygen. Then our atomic number is going to be 8, because atomic number is equal to protons. The mass number is protons and neutrons together, so 8 plus 9 is going to be 17. And then our nuclear symbol is going to be our symbol. The big number on top is going to be 17. The smaller number on the bottom is going to be your atomic number, so 17 over 8. The isotope name is going to be oxygen. You could either write out oxygen or just put the symbol. Oxygen dash, and this is going to be 17. Which oxygen is it? There are a bunch of different isotopes. Which one is it? It's 17. If you just put oxygen 8, that would be very redundant, because everybody knows that oxygen is atomic number 8. What people don't know is which specific isotope you're talking about, so that's the information you need to put when you write the isotope name, the mass number. All right, is it a metal, nonmetal, or metalloid? The right side of this stair step, see the stair step over here on the periodic table? Anything to the right of that are nonmetals, so this is a nonmetal. Anything to the left of that are metals, and anything touching it, pretty much with the exception of aluminum, are metalloids, or semi-metals. Same thing. Okay. All right, magnesium. Magnesium is over here, element number 12. So it's got 12 protons. Its atomic number is 12. If it's going to have 12 protons, it's going to have 12 electrons. Hopefully by now you know it's not happy with those 12 electrons. It actually wants to kick out 2 and go down to 10. But for this, we're just dealing with neutral atoms. Later on, we'll deal with ions. Atoms are all neutral, so if you have 12 protons, you got 12 electrons. The mass number is neutrons plus protons, so that's going to be 25. Then we look at the nuclear symbol, big number over the small number, 25 over 12, and then you write Mg next to it. Mg-25, and it's a metal. It's on the left side of the stair step. And finally, we got iron here. Now we have enough information in this nuclear symbol to complete the whole thing without even looking at the periodic table. First up, we know the symbol. We know it's iron. Next, we know 26 is the number of protons because that's the atomic number. And we also know if you have 26 protons, you have 26 electrons. We know 56 is the mass number, and if we do 56 minus 26, 30 is our number of neutrons. So then we can just complete this last isotope name, Fe-56, and it is clearly a metal because it's in the middle. It's actually a transition metal, any of these guys in this D block here. These guys up here in the D block are transition metals. These guys down here are the inner transition metals. Okay, in the F block. But those guys are all metals because they're on the left side of the periodic table. Now, number 8, last one. It says calculate the average atomic mass for the 2 isotopes of chlorine. So we know that one chlorine's 35, we got a mass of 35, the other one's got a mass of 37. Now, the 35 is really abundant. 3/4 of the time you're going to run into 35, or only 1/4 of the time you're going to run into the isotope chlorine 37. So we have to take that into consideration. It's not just a 50-50 split. If they were each around 50% of the time, then we would say what's in the middle between 35 and 37? Boom, 36, there's our average. This is not just doing the old school averages here. Now you have to take into consideration the percentages that they're abundant in. So what you're going to do is take the mass times the percentage. Make sure you move your decimal point over. 75.77 turns into 0.7577. And then this one turns into 0.2423. So you multiply them and you get your subtotal. When you do that, you get 26.52 and 8.97. Add them up, you get about 35.49. And then when you look at that, you can just round to the tenths place like we typically do, 35.5. That's AMU if you're dealing with 1. If you're dealing with a mole of them, it could be 35.5 grams. Okay, so 2 isotopes, you can't just take the average smack in the middle. What you have to do is consider the percentages, so you multiply, get your subtotal, and add them up. All right, all done with this section.